Hello, my name is Carly Rundle, and today I will be presenting research conducted at the University of Illinois in collaboration with DuPont Animal Nutrition, investigating the effects of increasing phytase dose to 1,000 FTU per kilogram on phosphorus and calcium digestibility in pigs fed diets without inorganic phosphorus. Phytate is the main form of phosphorus found in plant feed ingredients, including seeds, nuts, legumes, and grains, with about 50 to 60% of phosphorus bound to phytate. This phytate can form complexes with minerals including zinc, copper, manganese, calcium, and iron, and therefore reduces the digestibility and absorption of many minerals. As phosphorus is a required nutrient with a crucial role in bone formation, acid-base balance, and general metabolic function, it is crucial that pigs obtain optimum levels of phosphorus in the diet. Phytase is an enzyme that catalyzes the release of phytate complexes. However, intrinsic concentration of phytase is very low in corn and legumes, common ingredients in diets fed to pigs in the United States. There is also some phytase expressed in the gastrointestinal tract of pigs, which may result in additional cleaving of the phytate to yield available phosphorus and calcium for absorption by the pig. However, this is not enough for optimal utilization of feed ingredients. As a result, exogenous microbial phytase produced on a large scale through cellulosic biomass fermentation is added to diets fed to pigs to maximize digestion and absorption of phosphorus in order to reduce feed costs associated with including inorganic sources of phosphorus. This increase in digestion and absorption of phosphorus has been shown to improve the growth performance of pigs, including increases in average daily gain and the gain-to-feed ratio, and it has also been shown to improve bone strength and bone density, resulting in an improvement in overall health of the animal. Including phytase in diets fed to pigs may then result in a reduction in feed cost, as organic sources of phosphorus, including corn and legumes, are utilized more efficiently, and lower amounts of inorganic phosphorus may be included in the diet formulation. Another concern among producers and consumers alike is the environmental impact of the diets fed to pigs. Considering the phasing out of minerals such as zinc in livestock feed in the European Union, there is great interest in investigating ways to reduce mineral deposition in manure to lessen the effects of livestock production on the environment. Inclusion of phytase in diets fed to growing pigs may improve the digestibility of calcium and phosphorus, and subsequently reduce the environmental impact of mineral deposition in manure through reduced fecal excretion. Therefore, it was the hypothesis of this study that two sources of phytase, Butyroacella phytase from T. reesi, or phytase B as I will refer to it throughout this presentation, and a hybrid phytase from A. niger, or phytase H, would improve the digestibility and therefore decrease the fecal excretion of calcium and phosphorus when included in diets fed to growing pigs. There were 8 experimental diets in total. A positive control, or PC diet based on corn, wheat, canola meal, and soybean meal was formulated with monocalcium phosphate and limestone to contain 0.29% digestible phosphorus and 0.60% total calcium. The negative control, or NC diet, was then based on corn, wheat, canola meal, and soybean meal, and formulated to contain 0.19% digestible phosphorus and 0.48% total calcium, formulated with limestone, but without the inclusion of inorganic sources of phosphorus. 3 additional diets were formulated by adding either 250, 500, or 1,000 FTU per kilogram of phytase B from Butyroacella phytase to the negative control diet, and another 3 diets were formulated by adding either 250, 500, or 1,000 FTU of phytase H from the hybrid phytase to the negative control. 80 growing barrows with an initial body weight of around 12.8 kilograms were allotted to a randomized complete block design. The experimental period consisted of 12 days, in which days 1 through 5 were considered an adaptation to the diet. An indigestible marker was fed on day 6, and fecal output was collected from the passing of the first marker until a second indigestible marker fed on day 10 was passed. These samples were then dried in a forced air oven and finely ground prior to analysis. Diets, ingredients, and fecal samples were then analyzed for calcium and phosphorus concentration in order to determine the apparent total tract digestibility of these minerals. Apparent total tract digestibility was calculated by subtracting the amount of each mineral in the feces from the amount consumed in the feed and dividing that by the total amount of the mineral consumed in the feed, multiplied by 100 to get a percentage value. And now moving on to the results from this experiment. First, setting up the graphs, on the x-axis we have the PC and NC treatments in gray bars, the phytase B treatments shown in blue bars with either 250, 500, or 1000 FTU, and the phytase H treatments shown in orange bars with either 250, 500, or 1000 FTU. And on the y-axis is the dependent variable. This slide depicts the feed intake in grams per day, and here we can see that there was no difference in feed intake among treatments. When comparing both calcium and phosphorus intake in grams per day among treatments, there was a decrease in intake from the PC to the NC diet, which is expected due to the decreased calcium and phosphorus in the formulation of the negative control diet. There were no differences in feed intake on calcium and phosphorus among the pigs fed diets containing phytase. Next, looking at fecal excretion of calcium in grams per day, we observed that there was a reduction in excretion of calcium from the PC to the NC diet as expected. We also observed both a linear and a quadratic reduction in the fecal calcium excretion as both phytase sources were included, with the lowest excretion observed in the 1000 FTU treatments. Comparing sources of phytase, it was also observed that phytase B reduced excretion of calcium to a greater extent than phytase H. Comparing the apparent total tract digestibility, or ATTD, of calcium in percent among treatments, we observed a slight increase in the digestibility of calcium in the NC diet compared with the PC diet. Additionally, there is both a linear and a quadratic effect of both phytase sources on the digestibility, with the greatest digestibility observed in the 1000 FTU treatment for both phytase sources. Comparing sources, inclusion of phytase B resulted in a greater digestibility than phytase H. The reduction in fecal excretion can largely be attributed to the increase in ATTD observed on this slide. Next, looking at the fecal excretion of phosphorus in grams per day, we observed a decrease in the excretion of phosphorus in the NC diet compared with the PC diet as expected. There was a linear effect of both phytase sources on the fecal excretion of phosphorus, with the lowest excretion in the 1000 FTU treatments for both phytase sources. Additionally, a quadratic decrease in the fecal excretion of phosphorus was observed among phytase B treatments. Comparing the two sources of phytase B inclusion resulted in a greater reduction of fecal excretion of phosphorus compared with phytase H. Comparing the ATTD of phosphorus in percent among treatments, we observed no difference in the ATTD of phosphorus between the PC and NC diets. There were both linear and quadratic effects of the two sources of phytase, with the greatest digestibility of phosphorus observed in the 1000 FTU treatments for both sources. Finally, comparing the two sources of phytase, the ATTD of phosphorus was greater by the pigs fed the phytase B treatments. From this experiment, we can conclude that both phytase B and phytase H increased the apparent total tract digestibility of calcium and phosphorus and reduced fecal calcium and phosphorus excretion in a dose-dependent manner, with phytase B having a greater effect on increasing the digestibility of these minerals than phytase H, indicating that both sources of phytase may be included in diets fed to growing pigs to improve the utilization of organic sources of phosphorus compared with conventional inorganic sources of phosphorus. Future research should be conducted in order to determine the optimum levels of both sources of phytase in later stages of the growing phase and finishing phase of production for maximum digestibility of calcium and phosphorus by pigs when included in diets without inorganic sources of phosphorus. I would like to thank DuPont Animal Nutrition for their financial support of this experiment. And with that, I would like to thank you for listening to my presentation And if you would like to know more about the research conducted in the Hans Stein Monogastric Nutrition Laboratory, that information can be found at nutrition.ansi.illinois.edu.